So this is lesson 7.1 in college trigonometry, oblique triangles, and the law of sines. Alright, we're kind of on a downward spiral here. We've got a couple chapters left, and they seem to get a little bit easier than what we did in chapters 5 and 6, so that should be good news. Okay, so up until now, our work with triangles has been limited to right triangles, the book says. If any three of the 6 measures of a triangle are known, the 3 angles and the 3 sides, and at least one is the length of a side, then the other measurements can be known. This is called solving the triangle. So we have 3 different axioms there in the middle of the page: side, angle, angle, and side, side, side. I'm going to let you read that on your own. And jump down a little bit. A triangle that is not a triangle, or is not a right triangle, is called an oblique triangle. The measures of the 3 sides and the 3 angles of a triangle can be found if at least one side and any other measures are known. Very important to realize. If we've got a triangle, all we have to know is the length of one side and 2 other measures. That is supposed to be a 2. So if that is 32, it doesn't matter if we know the other 2 angles, the other 2 sides, or what. As long as we know 3 different measures of the 6, 3 angles and 3 sides, and one of those is a length. We don't care which one is the length. As long as one of them is, then we can solve it. We can find the other measures. Alright, so we have to be given 3 bits of information in order to find the other 3 parts of the triangle. Alright, so we have bottom of page 277. I'm not going to go through on how they derive the law of sines, but if we have a triangle that is not a 90-degree angle to where we can use sine, cosine, tangent, etc. in order to find the angles and the sides and the Pythagorean theorem, because Pythagorean theorem only works for right triangles, then we have what is called the law of sines. So the law of sines says that the length of A over the sine of angle A is going to be B over the sine of the angle of B. And that works with all of them. I mean, you see they give you a couple different ones. They're saying that line of A, sine of A equals C over the sine of C, and B over the sine of B equals C over the sine of C. Now, it doesn't matter if these are this way or they're this way, because you're going to do cross multiplication, so it doesn't matter which ones you put on top and which ones you do on the bottom. But I would suggest that whichever way you do this, whether you use it with the line on top and the angles on bottom, or the angles on top or the lines on the bottom, that you find out what they're looking for. If they're looking for the length of a line, use this formula because your lines are on top. If they're looking for an angle, use this formula because the angles are on top. And you'll just find that it's easier. It doesn't matter, but you'll just find that it's easier to solve, that whatever you're looking for is in the numerator position. So if you're looking for an angle, use this one because the angles are in the numerator. If you're looking for a line, use this one because the lines are in the numerator. So again, doesn't matter, but it does make it easier. Okay, this is figure 2 in your book, and it says use the law of sines to solve this triangle. So what are we given? We're given 3 parts of this triangle, which we have to, and one of them has to be a side, and then we're going to find this angle and the length of A and the length of B. Well, the length of C is easy to find because you know that a triangle has 180 degrees, so you're going to take the difference between 180 and 81.8 and 32, and you're going to get a C value of 66.2 degrees. So that's pretty easy and painless to find that angle there. Alright, now in order to find, let's say, the length of B, we're going to have our unknown on top, sine of B, And then something that we know, well, we know the length of A, so we're going to use that one. Alright, so we're looking for B. We know the angle of B is 81.8, and we know the length of A is 42.9, and that's going to be over sine of 32. Alright, so that being the case, this is the only unknown. So I'm going to take the sine of 32, and actually what you're doing is you're cross multiplying, and a simple way to do this is just to write this as B equals sine of 81.8 times 42.9 cross multiply divided by the sine of 32. Alright, so now I can find B. I just get my calculator, find sine of 81.8, multiply that by 42.9, divide that by the sine of 32, and I get B equals 80.1. You're far enough along that I don't have to go through exactly how to solve that and all the details there. So that gives me the length of B, 80.1. And then I do the same thing in order to find my C. Alright, so just real quickly, instead of using this formula, I'm going to use the other sine, law of sine formula, and I'm going to instead, since I'm looking for C now instead of B, I'm not going to use that one. I'm just going to use C. Sine of C equals A sine of A. Or I could have used B over sine of B. Doesn't really matter as long as the one I'm looking for is part of the equation. And I do the same thing. Cross multiply and then solve for C. Okay, so that takes us to the next example that we'll put on the second video here.